I'll make you hurry, okay, through the presentations. Feel free to stop me any place and ask questions. And I'm here to share what I've learned, and also I'm here to learn from you all. Okay. So as you see, my name is Sucharitha. I'm a Microservices architect in a company called Beacon. Just briefly about what we do at Beacon. It's a personal finance software company, and till recently we were part of Intuit. And we became a separate company little under 2 years ago. And then what happened was, when we were part of Intuit, we had all their cloud services that we could use. And as we separated over the past 2 years, we started our journey to build our own cloud infrastructure and rebuild everything that we had in Intuit on our cloud. So it's been a wonderful journey and a lot of learnings. And of course, we tripped ourselves and continuing to trip. So we learn, and it's a journey, I would say. Okay? And that's what I'm here for, to share what we can. Good? So the agenda really quickly, a brief history of software architecture. And from that history and all that journey, you'll see some patterns emerging. And you'll see something has to change, right? That's a motivation for microservices architecture. And you heard Anand this morning talk about 4 different architecture styles, right? CQRS, event sourcing, NTR, WebQ. Now it's you can think of it as a 5th architectural style. So that we'll see how it contrasts. And then I want to talk about, majority of the time I want to spend on design principles, right? How do one goes about building microservices and what things to avoid. Right? And then I kind of put it together as a blueprint. Big takeaway I would say for you all to take the blueprint. And of course you can make enhancements, but this is a blueprint you can start. Right? So for the next topic, right, a brief history, I just want to get a show of hands. How many of you heard about microservices architecture? No. And how many of you are actively implementing using microservices pattern? So I think I will briefly go through it. I'll skip through initial slides quickly because all of you heard about microservices, why they came about. But that gives me a little bit of providing the context. So hence I have those initial slides. Bear with me if it's a repetition, if it's something that you know of. Okay. With that, so a little bit the history of software architecture. I'm really going backwards, right? Way back into late 90s. And early 2000s. I just want to paint a picture, what software architecture meant at that time, right? So a lot of changes started to occur during those times, right? What those changes are in the technology landscape. Every business was going online, right? Literally everything was going online. Everybody wanted to sell stuff online in US, right? This is all happening all over. And then you saw enterprise applications. Even people who are not selling anything in enterprise business applications, they want to put out thin clients. You have heard about this term a lot, right? Thin clients. Along with other clients they had, they called them thick clients. Okay? Java was becoming a language of choice. Right? Just whole industry was coming out of C++, Corba, and then they just are starting to embrace Java as a programming language of choice for web applications. And JDOE, remember this? So JDOE, Java 2 Enterprise Edition, was becoming a platform of choice. It's providing all those bells and whistles needed to build an enterprise application. And then the architecture pattern that Anand shared about, the 3-tier architecture, got really popular as an architecture choice. That's the blueprint people were using to build any web application. Okay? So very quickly, we talked a lot this morning, so I'm not going to spend too much time. But this is essentially how any application built those days use this pattern, right? You have your UI tier, business logic tier, database tier. From UI tier, and of course browser talks to it in HTTP, and UI tier talks to business logic using RMI, and then use JDBC to talk to database tier. So all these are written in Java, so it's a JDBC. And then if you see UI tier, remember JSP servlets before SPA and before JavaScript became popular. Those are the technologies used to build UI. And business logic tier, again these are all written in Java, but specific technologies we used to use, EJBs, right? And then of course database tier, various databases. And then came mid 2000s, right? So what happened by then, people getting the reality shock with the J2E. J2E beginning to crumble, I would say. EJBs, enterprise Java beans, anybody who worked on enterprise Java beans know this, they began to crumble because of subpar performance. Lots of issues, inflexibility, etc. Right? And then you remember these WebSphere, WebLogic, very expensive application servers. And you need application servers to host your enterprise Java beans. Okay? Very expensive. And then generally I think this technology went out of favor. Right? And then we need an alternate. Right? Obviously you need an alternate. Open source momentum was beginning to start. And then that's where Spring platform coupled with lots of open source packages like Hibernate, all of them became really popular as an open source alternative. And the main thing is you can just run Spring-based application in Tomcat, which is open source, right? Highly scalable web server. And while this is happening, you remember 3 tiers, now suddenly it became 2 tiers. Right? With Spring, what I noticed, based on what I worked on the applications, they all became, logical tiers, became layers actually. Right? So slowly it became like this. A lot of applications by middle of 2000, business logic kind of got merged with UI tier, though they are separated but logical. You have your structs, action classes, and you have your types based on the ASP servlets, and you have Java classes, Spring Beans in business tier, which is doing database operations, but they're all in together. What I mean by together is they're logically separated, they're no longer physically separated. So it became like a huge gigantic monolith. Right? Okay, now for the rest of the presentation, I want to take you through using a sample application. That way it's easy for you to visualize what I'm explaining. So let's say I'm trying to build a blogging application. So this is what my PM product managers came up with. As Anish said, I want to sign up users. Users can create and update their blogs, and they can create communities, share all these blogs with communities, etc. Right? Very simple, basic blogging application. So I built that with 3-tier. 2 logical tiers. This is how I have all my logic nicely separated, but they are all again logical. Right? If you see in the middle, business logic tier, user service, blog service, community service, they are all Spring Beans. So they are singletons, but they are all in Java and coupled with UI code. And then product managers added more to my plate, and then I start doing this. Then it became this. I started adding more services. It was all designed nicely, and then people continue to design nicely, so they're all segregated. And some more utility classes, helper classes, it's all getting added to the same code base, right? And you can see database also growing, right? To support those features. Then came 2006. If you remember, we all started B2B, right? B2C and then B2B. Oh, we all want to integrate. Then came web services, right? How do you want to expose your business functionality to other businesses? Oh, let's do web services, right? That's where SOAP web services became really popular. And then 2 years later, 2006-07 timeframe, what the web services became thick, then became bulky. They came up with lots of standards. If you remember WS star standards, security, transaction became really complex for anybody to understand and implement. So then said, let's simplify. So then came REST, right? So RESTful web services gained popularity, and then REST APIs got added to already available code base. It's all in the same code base, right? I don't keep rebuilding my application every 2 years. But I still have to make progress. So I keep adding layers and layers on top of the existing code. Then, this is how my code was, and then more classes got added to the same code base. And then I hope I'm reusing sometimes, and some developers will say, I don't want to touch this code and let me add my own class. So it becomes like this, more utility classes, more layers, you have SOAP web services, you have RESTful controller classes, and it keeps ballooning. Right? So the reality is, by 2010, most applications have become big monoliths. Right? That's a reality. Any application you look at that is started in early 2000, by 2010, it should have become a balloon into a big monolith. While a lot of things have changed around it. Right? If you think about it, in the middle of 2000s, a lot of things were beginning to change. Not the code base. Process got innovative. If you remember those days of waterfall, suddenly everybody wants to do Scrum. Right? It's all same functionality, but we want to chunk it and then do this much first and do this later, and then we want to use a very highly iterative model. Right? Scrum became popular, and then team structure changed too. Right? We have Scrum teams, and some companies have geographically distributed teams as well, working all in the same code base. Right? And business models evolved too. Right? Earlier in waterfall and those days, on-prem applications, it's okay, you take a little longer to release. Right? And there is a lot of hand-holding to the customers. There is professional services will hand-hold customers through upgrades, there is not so much friction. But with online applications, people want, product managers, customers want every feature like yesterday. Right? Not today or tomorrow, they want it, it's already made. So that's how the business models have evolved. But if the reality that we were living in by 2010 for majority of the applications is code-based architecture, you may say. For all the right reasons, you can't suddenly wake up one day and then say, I'm going to change it. Right? You can't do it. So, but status quo was no longer sustainable. You can see developers screaming, QA screaming, PM screaming, everybody screaming at each other. In Scrum, it's almost fine. You can't do this, you can't do this. So status quo no longer sustainable. That's when microservices architecture got born. Right? And 2010, it was not called microservices, but a lot of companies like Netflix and Twitter's modern applications started to embrace microservices, but just it was not called microservices. They figured out what is that we can do to release features every day, right? And try them out. I want to A/B test. I want to release this feature today and get some feedback. Why do I have to wait 2 months to finish everything, deploy this whole monolith, etc. Right? They wanted to reduce that friction. That is when microservices architecture came, right? So, based on what I mentioned, what are the expectations from architecture, right? So from dev teams, they want to be able to enhance easily. I don't want to impact, so many other things. All I need to change is one line of code. Now I have to do impact analysis, give all this list of use cases, list of test cases to, testing teams. So I want to be able to easily enhance. I want to easily upgrade, right? Underlying software packages. Remember, you cannot change Hibernate version from 4 to 5 without big discussion and, it takes 2 months to plan. What about Java upgrade, 1.6 to 1.8? It's a mammoth task, right? So I want to be able to do it, I want to experiment with this. Why do you need a permission for so many people? So these are all the pain points from dev teams. And I want to work parallelly with other people. How many times your manager, escalation went to your manager and said, stop building more stuff, stop check-ins, everything stops, you go fix the main line. Build is breaking. It's a big monolith, everybody is working on the same code base. Inadvertently, advertently, it just gets broken every week. Okay? And a new dev member joins, no clue what the heck is going on, right? I don't know. So can somebody explain me? Nobody knows. Because 10 years later, whoever worked on the nice design at the beginning, they're no longer with the company, right? How do I understand this code base? Right? These are all the dilemmas dev teams have, right, with legacy applications. And then QA type teams, understandably, they want to be able to test and automate. How many people can vouch QA saying, I cannot automate this? What are you telling me? And every single change has to go through regression. For some reason they like regression. Right? Everything developer changes one line, they don't believe developer. Whatever developer says, no, I have to run regression, otherwise I get blamed. Right? So that game continues. Then comes ops teams. They want to be able to deploy, they don't have to think a lot. Of course they have to think a lot, but I'm just saying, they want to be able to deploy easily and then scale. Able to diagnose. Right now, if there is a problem with monolith, you have to bring down the whole thing and then where do you go through logs, figure out. Right? So these are all the expectations, right? And then now I go through, let me see if I can answer, meet those expectations through next slides. Okay? Everybody's okay? Okay, so first design principle. You saw that big monolith with lots of services, lots of utility classes, helper classes, layers, and etc. So split them into separate services. Right? Easy set that done. Right? This principle. The next design principle, we'll talk about this a little bit more detail. As you split them into services, when I say services, they are physically separate services. They are no longer logical. Right? And each service should own its data. It's a very important principle. Make sure that each service owns its data.
So what do you mean by own?
Yeah, I will go through it. Just the three principles. I don't have too many. The services should interact. Now that you have all these services doing stuff, they all need to interact, right? Sometimes. I'll also go through some patterns you can follow. Should interact with each other using a well-known interface. Right. Now I go through each one of them a little bit more detail. So as I said, it's not easy, right? Because we all think they're all connected in some way. So how can we split it? Right? That's why it's not easy. And some rules of thumb that at least helped me to visualize how I can separate. So split services by functionality. Right? If there are independent features, for example, blogs. If you blog service and then you have a following, you want users to follow your service. They have two different pieces of functionality. Maybe I can have a blog service that handles only CRUD operations on blog. And then there is a follow service, does following feature. And commenting. You want to comment on a blog, you can have its own service. So split services by functionality. So another way to split is background tasks into separate services. Right? So if there is a service that handles two things, one front-facing APIs that are facing the client applications, which are very response time sensitive. You want to respond under 2 seconds, right, for any web application. So make sure front-facing APIs, you put them in one service. And if you're launching a background task, for example, you want to send out an email, right? Because blogs are created, maybe there are people following the blog, you need to send out an email. That's a nice background task that you can hand it off to other service. Right? You don't have to do everything in that one service. So this one is very counterintuitive, okay? This is not what we are told 10 years ago. Right? Everybody said reuse, reuse, reuse. Right? What we realized after 10 years, even though you say reuse, people don't reuse. The reason is they don't know what they're breaking. How many times you have seen, at least I have seen, there is a function called create company. Right? Create company, there are 10 variations of same create company. Because they are afraid, what if I break this other flow? Maybe this web service I'll break it, maybe this REST service. You end up having multiple versions in the same code base. Right? But anyway, within the context of microservices, right? One thing you have to remember is don't try to over reuse. Right? Why do I say that? Let's say you nicely segregated blog service or follow service. But now there is a small utility. Think of string parsing, and I'm cleaning the string to remove some unwanted characters. Oh, you know what? I also need it in follow. Let me try to nicely create a library and reuse it. But then you are defeating the purpose, right? What if somebody goes changes that library? Now I have a dependency. Now I have to test blog service. Now I have to test my follow service, and both have to be brought down. Both have to be deployed, right? So just think about it. Unless you are very sure that you can manage that library in a way that you can make it backwards compatible, you can manage versioning. If you can do all that, think of creating a library. Otherwise, best is to not reuse. Okay, little bit counterintuitive, but we've learned the hard way.
Actually, Martin Fowler has written an article where he says, unless it is used in 3 different places, you keep it as 3. If you find it using in the 4th place, that's when you start considering a library.
Yeah.
So that means it is, fairly generic. So until you see 3 instances, you should, it says follow your rules.
Start with this,
Yeah.
and then you can see the pattern emerging. So main thing I found difficult is to manage backwards compatibility. I have to think so much to change one line in a common library, right? What if I'm affecting some other service? Right? But some things make sense, like authentication. You don't want to keep doing it, right? Something like error processing, maybe error logs. But I think this rule pretty much works at as a starting point.
One more question on the split services of functionality. Businesses typically try to merge functionalities and break functionalities like as if they have it ready yesterday, right?
Yeah.
The more you split services with functionality, to merge them together to get a composite view becomes a challenge.
Yes.
Have you faced it? Just a perspective.
Yeah. So we do face it. This dilemma is always there, whether to split it or keep it merged. So that's what I'm saying. So if you're not clear, start with keeping it together. But having said that, let's say you decided, even though you put in a lot of thinking, separated them out, now you have a need to build those composite views. So that's where you put what we call it as an application service. So that's a pattern that we're trying to embrace, especially if you have multiple clients. Let's say you have mobile clients, web clients, thick clients, legacy, right? If you have to support various thick clients, they all have different needs. Some may need a portion of the information, some may need. So what we call is we put an application service layer in between. They are again API driven. It will go and aggregate data from multiple services behind and create those purpose-built views. So don't again reuse application services. Right? Mobile application service, you can call it, and web application service.
Here you try to orchestrate the player.
Yeah. You orchestrate. Yes, sir.
My question is, you are trying to orchestrate these things or are you trying to create a player?
I think let me answer that. So what we follow is, we have a system APIs which are fairly fine-grained. We have a process API that in fact calls these system APIs in a particular order to provide processes. We have an experience API on top. It depends on whether you want to split by functionality or by domain. Again, it goes to different styles of architecture. We prefer domain. Blog is a domain for us. Blog is a domain for us. We keep the service. For example, in this example, probably we will design blog as a domain, and any capabilities that we want to expose out of the blog would be a service on the blog service. That would be a user authenticated user set of services, create user, modify user, edit. Again, if you want to do by functionality, like in this example, again, you can have your fine-grained services which your system APIs. Then you write your follow user is probably a process API. It kind of uses 2 system APIs, and then you may have an experience API. So if you layer the APIs that way, then the process API is the one where you mix and match the system APIs to provide a business capability.
You want to use the mic? I can't hear you. Sorry.
Yeah, my question is, you are trying to orchestrate. Orchestrate means basically you say that, okay, I will do these things, then I will do this, then I will do this. But choreograph means each person dance, right? That stays. So what you are trying to do? Because each has its advantage, disadvantage. And if you are pointing this context, microservice architecture, right?
Yeah, so the application service design pattern is something that you can think of as an orchestration layer, right? So there is also 2 different styles of orchestration. One is view. If you are creating a what you call materialized view of a web application. Let's say I am building a web application. On the front page, So I need to show 10 things, blogs, followers, comments on the same page, right? So essentially you have to go and get this information from 3 different services with microservices, right? So you have to make 3 calls to create that one view. So you can build a thin layer, which is a very stateless, it has no database access, nothing. It's called a web application service. All it does is creates that view for the front page. So that front page loads really quickly. So that application service goes and grabs data from blog service, grabs data from follow service, and also from comment service. And put it together and create an API just for web. Don't try to reuse too much. Just keep it very purpose built for web. Then came mobile application. Let's say a year later, then you build mobile application service. And that actually, the way pattern we are following is that application service is the responsibility of the mobile team. They can build the way they want. We have given you these APIs because if we are a backend team, let's say, I take ownership of application service layer, what happens is their requirements keep changing, right? And it becomes a burden if I have to support 3 different ones. So we even are saying the application team own that application service layer, you build the way you want to build it. And they can directly come to us also, nothing stopping. But if they want a middle tier, they can build it. Then comes, orchestration. Orchestration, another way of what I'm alluding to, right, processing, where there is a write involved, there is a transaction involved. So then it becomes a little bit complex. So that's where I'll get to that in a bit.
It's called the BAP, backend for front. What you're talking about is service, right? So it's a backend for front end where because there would be different, because the service is providing the data.
Yeah.
And there could be different types of clients. For mobile needs only few data, whereas a web application might need more data. So I think this is more called as a backend for front end.
Yeah.
Right. So the service which you're talking about is the design pattern of, they call it as a backend for front end.
Yeah.
So you have different layers where your UI or the front end interacts with, and this actually interacts with your actual API to get the data.
Exactly. So this is all backend infrastructure, how you can use microservices. See, now with the single page architecture with JavaScript, there is no UI tier. It kind of moved to the device, and this application layer, you insert it only if you need it, right? For mobile, you don't want to use up bandwidth by doing a chatty communication. If I have to, get information from 10 services, I'm making 10 calls. It makes very good sense to create that application service layer. And the application service layer, you can think of building it in Node.js. It's a very good use case for Node.js.
Because this also helps to do load balancing using client-side load balancing than services.
So you're just showing a point that the definition or how you create the APIs or the microservices API itself is driven with the client. And a lot of backend developers don't have the insight into how the clients are being developed. They are just building APIs in a more generic way. How do you see that? Because I always feel that the backend developers are just worried about the database, as you said, the data and this, and they are not keeping in mind the front end. Yeah. But when Netflix built it actually kept in mind the front end and what the front end needs.
I mean, that's where they actually got application service layer in the picture. For Netflix, it became really, really complex to manage client teams, right? Because they have, think about, we only have 3 clients. Netflix has hundreds of clients, right? Every little device that has a Netflix app. There is a Nintendo Netflix app, there is an Xbox Netflix app. Every device that you can think of has a Netflix app. So there come a point where they are not able to sustain. This API layer team, I said, okay, I give up. So they even went one step further to create this application service layer where it works in a self-serve mode. Each client can plug in their application aggregation layer into it, right? So going back to client teams and server teams, there's always this friction. Server team doesn't listen to me what I want. The way we circumvented over the years is to build that feature teams, right? It's no longer. Initially we had backend Scrum teams, front end some Scrum teams. It's a project manager for some reason is in the middle caught, and product managers. They are the ones who are thinking, okay, what the hell are you building? You guys need to talk. So then we kind of went to the model of feature teams. Come on guys, you all be in the same team and fight it out, how the API should be, right? And at the end of the day, the way I at least explain to backend folks is, your service is useless if it's not used. Okay? You can build 10 APIs. If it's not useful, at the end of the day, what you did is waste of time. Okay? So,
I think we should call it a capability. Right? What we call it a capability. Such is a capability. It includes the front end, the back end, the indexing layer as a vertical thing. We call it a business capability. So as long as you decide, you go with your back end or the front end and different segregations, and you talk about the business functionality as a whole, then I think all the conversations around me versus you will go away.
exactly. So you're ultimately, helping the customer.